Number 7 is taken from the International Edexcel A-Levels Math Pure 2 Sample Assessment Material 2018. The circle with the following equation has center C and radius R. Find the coordinates of C. Now, in order to find the coordinates of C, we need first to know the general equation of a circle, which is represented by x minus a squared plus y minus b squared equals to r squared, where a and b represent the coordinates of the center of the circle. So in here we have an expanded form of the equation of a circle, so we need to change it to this form. In order to change it to this form, we have to complete the square. Before completing the square, we need to arrange the x's together and the y's together in this form, and then we need to take these and complete the square. Now, in order to complete the square for x squared minus 20x, we take 20 and we divide it by 2, it's equal to 10. Then we square 10, we get 100, and then we use this 10 in order to write the perfect square form directly, and take into consideration or be careful that the sign which is in the perfect square is represented by the sign which is found here. So x minus 10 squared is the perfect square for the first part, or for the representation of x, and we have here y squared minus 16y, so you take the 16 and divide it by 2, you get 8, and then you square it, you get 64, and the 8 is used to complete the square or to write the perfect square of this form, keeping in mind that the sign here is taken from this sign. So if this was plus, then inside the perfect square is going to be plus. If this was minus, so it's going to be minus. Now you can see here that we have subtracted these two numbers, and these two numbers, they represent the square of 10 and the square of 8. So in order for us not to change the equation that we have and to keep it as it is, for us to complete the square, you have to write it as a perfect square and deduct or subtract the square of this number that you used. Same thing for the part here, you subtract the square of the number that you used in your perfect square. Then we need to collecting and taking it to the other side is the representation of r squared. So minus 100 minus 64 plus 139 gives you minus 25. When you take it to the other side of the equal, it becomes plus 25. So this is the way that we have to write the general form of the equation of a circle. So now, in order for us to find the coordinates of C, we take 10 as the x of C and 8 as the y of C, because x minus a, so 10 is a squared, plus y minus b squared, 8 is for b. In part B, show that r is 5. When you take the square root of 25, 25 represents r squared. When you take the square root, it's plus or minus 5. But since we are working with the length, therefore you take the positive. This is why you have r equals to 5. Now we continue to part C. The line with equation x equals 3 crosses the circle at points P and Q. So the line that has an equation x equal a number, it's the line which is parallel to the y-axis, and the x-intercept is the 13, which is found here. So crosses the circle at point P and Q as shown in the figure. Find the y coordinate of P and the y coordinate of Q. Now, since P and Q lie on the equation of the line x equals 13, therefore the x of P is 13 and the x of Q is 13. So we only need to replace this 13 in the equation of a circle and find the y. Now, when we replace 13 instead of x, we will have a quadratic equation, and after finding the quadratic equation, we find two values for y. One would be for P and one would be for Q. So when x is equal to 13, you replace 13 by x, you replace x by 13, and then you find y using algebra. In this case here I solved for y without expanding. So y minus 8 squared is equal to 16. So y minus 8, you take the square root on both sides. So y minus 8 is equal to plus or minus square root 16, which is equal to plus or minus 4. So one time you take y plus 4. So here you have y minus 8 is 4. Then you take the 8 to the other side, therefore y is 12. And one time you take y minus 8 to be minus 4. And you take the minus 8 to the other side, it becomes plus 8, so y equals 4. Therefore, P would have y of P is 12 and y of Q is 4 according to the graph or to the figure that we have here. The last part, which is D, a tangent to the circle from O touches the circle at X. So if you draw a tangent to the circle from the origin, it should touches the curve, the circle at X. Since it is tangent, therefore it only intersected at X, 1 point. Find in third form the length of OX. We know that that O has coordinates 0, 0. Now we need to find the value of the coordinates of X, or we need to use another method in order for us to solve and find this measure or this length. So X is the radius 5. We need only to find OC. The length of OC, we can find it because O is the origin and we have its coordinates, and C we already found in part A the coordinates of C. So we find the length of OC using the formula square root of x of C minus x of O squared plus y of C minus y of O squared. Using algebra, we plug in the numbers and we find the square root of OC, which is the distance from O to C. Then, since we have OCX if you look at the figure, you find or you notice that OCX is a right triangle. Since it is tangent, therefore the tangent makes a 90-degree angle with the radius of the circle. Therefore we have CX, which is the radius, and we found the distance of the hypotenuse OC using the distance formula. Therefore we say that the distance OX squared n equals to OC squared minus CX squared using Pythagoras theorem, where OC is the hypotenuse in the right triangle CXO and CX is the short leg. Therefore, using algebra, we can find the value for OX. And in this case, we replace OC squared by its value and CX by the value that we found, subtract them from each other, and we get OX squared is 139. Therefore, OX is square root of 139, and they want us to keep the answer in search, so this is why the answer is kept as it is. It's not written in a decimal form.